So good morning, everybody. Thanks for having me. In this session, I'll share how we did the restructuring of our incident response and root cause investigation processes, walking you through elements used to structure the process, tools, and the investigation itself. I am Joao, and I work for Siemens Healthineers, a medical device, medical technology company based in Germany, in Erlangen, but with a global presence. That's where I am coming from. In this session, we'll have 4 main blocks. First and foremost, the background. I think it's important that you understand a bit on what's the background that we're inserted. What does the threat landscape look like? What is it doing incident response for medical devices? And a little bit on our team journey that we are on. Then we proceed on to the approach. Let's understand what are the environmental constraints in this setting and what needs the stakeholders have. From there on, we proceed to structuring the investigation using an open source framework, the FIQ, that helps capturing knowledge. From there on, there are some takeaways that I would like to share with you. Some of you might be in a similar journey, and those should be useful. Thank you. So about the background. What is the situation like out there? How does the threat landscape look like in this healthcare sector? Sad reality, many documented cases of very high bounties being paid to threat actors, basically fueling this eagerness to hack and to sell data. That's a very bad thing. There's a huge incentive in these things for threat actors to target the healthcare sector, which is a very critical sector for society. Cyber attacks are considered the major risk for healthcare systems and are very frequently, if not every week, we have news of disrupted care, disrupted hospitals, preventing access to therapy or to diagnosis. So this is a very serious thing. But why do threat actors actually target healthcare? First and foremost, healthcare is unfortunately an easy target, is an easy prey. Stefan mentioned many of the basics, and this sector unfortunately lacks many of the basic things in cybersecurity. So there is a large and interconnected attack surface. Security practices are not the best, usually. Teams are also heavily understaffed and suffering under severe pressure. We all hear how critical the healthcare situation is, not only in Germany, but all over the place, basically. Second important factor here, complexity. Healthcare is an ecosystem that has several legacy systems. Security in these legacy systems was never built in upfront. Like when you start designing something, you think, okay, let's get it right from the beginning. But devices that are living for over 10 years, maybe 15 years, they were designed with clinical aspects in mind, and lately only with security, some sort of an add-on. Medical devices will also be operated for very long life cycles, 10, 15 years, I mentioned. From the clinical point of view, they are perfectly okay. They deliver good images, they deliver good values for your blood tests. However, patching cadence, that is being neglected. Yeah? And all in all, there is a very strong digitalization push to increase efficiency. Healthcare is expensive. Let's make it cheaper. Let's make it faster. Let's make it more efficient. The third factor, again, threat actors and selling data on criminal markets. Health data is unfortunately on the high price segment on criminal markets. So if a threat actor gets health data, chances are that he'll make good money out of it. Therefore, that is why there is this target, this focus on the healthcare, on obtaining healthcare data. So that's where we inserted. But as I mentioned, I come from medical technology company, and I work on the product security team. We do incident response for our products and solutions. That's a major difference between a CSIRT and a PSIRT. Maybe a quick show of hands here. Who of you are into incident response, investigation, root cause? Okay, so I would say less than the half of the room, but at least some of you are into this similar setting. But how many of you are also in a product security team? Are there many of you? I see one hand there. Two. Okay, awesome. Let's chat. Let's chat. Please come to me. So we do incident response for those products and solutions. One major difference here is that these assets, they do not belong. Typically, they will not belong to our company. They will belong to the customers. So they will be owned and operated by the customers. So we are inserted into this setting, and then we come in. Okay, something broke, something is wrong. Let's understand what happened here. But why actually do we need to investigate root cause? First and foremost, hospitals need to be back online treating patients. So recovery, you need to understand how the attack took place to make sure recovery is sustainable. To make sure actually the measures you take is re-imaging a system enough. You can only answer that if you know what happened, how did attackers breach your system. Second aspect, also very important, regulatory needs. There are some regulations concerning patient safety and clinical quality. So whenever there is a cybersecurity incident, there is an investigation started and needs to understand, was there actually any risk for patients or any risks for clinical quality, clinical data? That's the second aspect. The third one, which I think is the one that helps us on the longer term, is to enable continuous improvement. So when you understand how your products were breached, then you can derive improvements for the security architecture, for threat modeling, etc., as well as to improve customer care processes, to understand what your customers need and whether your processes are fulfilling their needs. The journey. So we're bringing out the next version of this service, and therefore we have a fantastic opportunity to review the process, the toolings, and the investigation itself. That's the journey we are. Jumping over to the approach. What elements we use here to redefine this process, tools, and the investigation? The very important one, the environment. So here is the environment where your forensics process, where you are operating your forensic process, where you're operating your incident response. The environment will provide you with very important constraints that you need to observe. Otherwise, your process will be prone to failure if you don't know the context where your process is operating on. Second one, the stakeholders. Stakeholders will have specific needs, questions to be answered that you need to observe in order to have a good process. The third aspect here is specialist knowledge, threat intelligence, supporting you understanding, okay, what are risks in my process? Are there things that am I overseeing? And then ensuring the process is complete. These three elements. And then from these elements, you start deriving the requirements for process, tools, and investigations. You understand also what kind of documentation. Documentation is especially important in my case because I will get to that later on. I am not going to the hospitals and acquiring forensic data. Someone else is doing on my behalf. So I have to make sure they have an easy life doing that. And the third one is when you know what the constraints are and what the needs are, then you can understand, okay, what do you actually need to answer with your investigation? Take one, let's talk a little bit about the environment. When I started working in this setting here, I was interviewing the colleagues, I was understanding from threat sharing groups, and discussing with people, having a dialogue to understand, okay, what are the fundamental constraints that we need to observe here? And first and foremost, whenever an incident hits and affects operation on a hospital, the customer care teams and the hospital staff will do the best they can, all they can, to get systems back up and running, to get back to treating patients. So that's the priority. Second aspect here, we discussed this a little bit, medical device will have very long life cycle. So in your investigation, you have to deal with legacy operating systems, legacy applications. And the third one, because priority is on recovery, the devices will get reimaged very early in this process. Whenever, as long as they can, they'll start reimaging device, reconfiguring to get them back online. That means you only have one shot to collect all the forensic evidence you need to do the analysis in the lab. On the right side, what does that mean for us, doing incident response on products being operated by customers in these hospital settings? First and foremost, do not, never, ever get on the way of recovery. If you become a burden to them, that's not going to work. They will not perform the collection that you need to perform your job. Second one, you will have like strange and exotic stuff on the field. Therefore, know your installed base, know your devices on the field, know your capabilities of your collection tools, and ensure these tools are compatible with this broader range of devices that will be on the field. And the third one is for you to take as much data as you need, but making sure you don't go beyond that. So basically, you have to strike the balance between a broader collection, but still keeping the data that you're collecting in manageable volumes. Do not make data collection take too long, yeah? All right, just take 10. Some fundamental differences, and I'll try to speed up a little bit. IT and healthcare incident response have very important differences. In the IT area, you have things like telemetry and automation. This is commonplace. This is everywhere. We're talking about these EDRs and what have you, detection, security operations center, detection and monitoring processes, orchestration, automation. So there is an abundance of tools for detection and containment. On healthcare cybersecurity, the incident response for medical devices is a bit different. First and foremost, there is often no integration. Even if the hospital has a security operations center or some sort of security monitoring, not all devices will be sending data to these central areas. The devices are also often designed with clinical features as a priority and not cybersecurity feature. I think during the keynote, Martin mentioned medical devices. No one is. It's like it just has to work. No one is going to pay extra features for extra money for these cybersecurity features. And so that's the case here. The focus is really on clinical aspects. Therefore, you have a scarcity of tools and methods for incident response, containment, etc. Second aspect here. Logistics, size matters. Smaller medical devices, what happens? Oh, this device is broken, this device is compromised. Someone comes in, takes the device out, puts it in a box, ships it to the manufacturer. Another device gets installed in, and then the manufacturer can work on the lab. Most of our devices, that's not applicable because those devices on an MRI scanner or a CT scanner, I just put a note there, 13 tons, so it's a logistic nightmare to install one of those devices in a hospital. So it's not possible to send them back to lab to me to analyze, so therefore we need to do the collection on the field. Okay, then we discussed a little bit on the constraints posed by the environment. This slide just illustrates a little bit of how do you start deriving requirements for your processes, tools, and for the investigation? And I'll be a bit shallow here. For instance, the first constraint here, restoring operations, because the focus of these field teams is not actually performing forensics on your behalf, on the behalf of the product security team. The job is to help the customer get systems back online. Therefore, keep it short. Second thing, long life cycles. You have to ensure compatibility of your tools. You have to provide alternative methods or even enable these teams to, if that's necessary, to collect a full disk image. And the third one, only one shot. That's my favorite constraint because that's the most interesting from the forensic engineering point of view. You cannot collect it all. That's too long, and you're going to generate too much data. It's not going to be practical. But then you have to prioritize. And there are things like it's a shootout for adaptive collection. Some Velociraptor just mentioned this, I think, 1 month ago or a couple of weeks ago. Basically, a side note, because I find this topic especially important for my setting, collectors, these forensic collectors, they will have a static list of files to be collected, artifacts to be collected. The adaptive one goes one step beyond this. It has a list, but then some of the selected artifacts will be parsed. And for instance, if there is a scheduled task, it's not automatically that a static collector will collect the binaries or the files referenced on this scheduled task. The adaptive collection parses these entries and then will collect these related files as well. Meaning it's a very big advantage if you are on a similar setting as I am. Just to be very blatant and placative here, that's incident response for logical medical device. Nowadays, that's the commonplace. Someone is walking with a USB stick that was hopefully sanitized and formatted before it was used. There is a collector installed here. This collector gets executed. There is a triage package being generated. That's when you can, and I can start working. So you have to make sure you provide this, plus a little bit of hardware specs, basically reliable sticks so that you don't lose data, and fast enough so that the right operation will be performed timely. Moving on to stakeholder needs, and I need to speed up, and I think that's the message now, yeah. Simplifying this a little bit, what personas we have here, and here I summarized this, or simplified this into three main personas. The customers, so basically hospitals, healthcare delivery organizations, responsible for business continuity and for patient care. And these folks, the ones, there is always a kind of IT department in a hospital, they are responsible for installing upgrades to address security flaws. Medical devices, I'm not sure if you're aware, but there is nothing like Windows patch day and then you install all the patches from Windows. That does not work like that. So the manufacturers, they have to produce update packages, and those updates are deployed on those devices. That's how you do vulnerability management for those things. So in the second persona here, the regulators, those will define conditions so that you can approve a device on a certain market and then sell the device. Their focus is patient safety and clinical aspects. Plus the third persona here, the manufacturer's R&D, so basically our folks, our engineering folks, our product development folks, responsible for security architecture of medical device safety and quality, and they must deliver upgrades to address security flaws. I will have to shorten things up. Here, just as example of investigation requirements, 4 main clusters. So basically the scoping, the first one, containing in isolation, the second one is enabling your customers to continue operations, although the network has been disrupted. The third one being in the investigation towards the integrity of clinical data. And the fourth one, also very important one, was that actually potential risk or actual risks for patient safety or clinical performance. Digital forensics is an enabler to all of those investigation clusters. Digital forensics is how you answer those stakeholders' questions. And then we're talking about investigation, we're talking about knowledge. Again, I have to hook on your presentation. Stefan mentioned so many ideas that you can capture to increase your knowledge base on digital forensics, where to look at things. And the FAQ is an open source framework that I'm starting to adopt to start codifying these ideas and those details. This is just, think about a catalog. This is just a catalog with a nice structure. These files are stored in YAML, so it's text format, it's easy to process, it's easy to maintain. Some benefits that I see from this, deliberate thinking, so you're pushing your teams, you're pushing your analysts in thinking about questions up front, and not when the situation is on fire, not when you have to explain something, so up front. Second thing, repeatability and explainability of your investigations. And the third one, quality and coverage. If you have a roadmap, you will have less gaps on your investigation. The structure of this thing, scenarios, facets, questions, and approach. Scenarios are really like the higher grouping, so how to start an investigation. If you think about an investigation, if you think about a scenario, you have certain angles, so certain facets of this investigation. That's what they call facets. So basically some sort of intermediary grouping between a scenario and actual forensic questions that you have to answer. So the questions is actually where the focus is here. What are questions and what are approaches? So basically questions and how to answer those questions. That's the structure provided by this framework. I've brought a scenario, but I think we have 2 minutes, right? Then just very simple and going very quickly over this. This is, it's a bit simplified, but it's an idea to illustrate. Someone called in, hey, we need help. There was apparently an infection of a system caused by a hard disk, or an infected hard disk. Then I receive the triage package and I start my investigation. And these are just like possibilities. Yeah? So you start thinking, okay, what devices, what USB devices were used on the systems? Then you be a little more specific, taking a look on removable storage devices and where the files actually transferred from USB towards the main drive of the device. Was there maybe, you have maybe metadata to tell if was there malware present on the device, things like auto-run or hidden folders. Then you proceed on with your investigation and some of the hypotheses here. Were there actually files executed from this device? Older devices, they were talking about auto-run here. Auto-run seems to be a thing from the past, but not in the healthcare realm. Did the user actually click something on the USB? There was a nice icon there saying, please click here, and there you have it. And then as you proceed on, deepening the investigation, then you might consider, okay, what are affected changes on the systems, changes to users, to user accounts, created files. How does the persistency-wise, how is the situation? Run keys, auto-start items, etc., etc. Maybe we could even be so lucky from parsing an MFT and see, okay, there was a huge zip file being created. That's where exfiltration likely is. Yeah. All these things you can capture in the structure of the FIQ. Some of them are also already present in the project. This is just a print out of the website. And one example here was data exfiltration. This is like the scenario. The facet here, are there signs of staging for data exfiltration? And then they have the specific, those so-called atomic questions. For instance, were there files downloaded using a web browser? And if you delve into that question, they will even go as far as providing an approach with different techniques and different data source and analytic techniques. Takeaways, and I have to be very, very fast, but basically 3 main things. I think Martin on the keynote already mentioned establish a dialogue with your stakeholders, with your peers. So basically, so first the environment. So know the environment where your process is inserted into. How do you acquire data? Is something like remote executions of your collection tools available? Do you have telemetry available remotely? Know your systems. Is there people working on our behalf? So you have to know, okay, what are those people's capability? How much time do they have to help you? Know your stakeholders, so basically establish the dialogues. What are the objectives? What are their objectives in the investigation? What questions they need to be answered. From those questions, which are the ones that must be answered urgently? So as soon as you start going, typically around scoping and containment, for me, an example would be, I need to tell the customer these and these systems were seen attacking our medical device. So this would be a very important insight to deliver as early as possible to the customer. While maybe there are others that could be delivered a little later on. So after you did the scope and containment, what I call downstream products. So secure improvements to the security architecture or threat modeling or even further techniques or further aspects of customer care process. Specialist knowledge. So the threat landscape is also another important source for your collection and analysis requirements. What attack techniques are relevant for you. Review your past incidents. You will learn a lot when you review your past incidents. Make sure you're capturing artifacts that will enable you to answer questions around those incidents, around those past attacks. Anti-forensics, also something to be to be considered. Thank you very much.
Thank you, Joao, for keeping everything on time. I must say, as a person who has worked in incident response, I appreciate your traffic light protocol, Collier, and that you're talking about open source frameworks that we can use to actually analyze and learn as defenders how can we improve. So you actually answered my first question through the presentation of how to start root causing with the USB drive. I'm glad that it wasn't with diskettes or something like that. But
could have been, you don't know.
Maybe a first question I have is, what are the most overlooked factors that contribute to recurring security incidents, and maybe how can we use the framework to address them?
I think what comes to my mind with this question is really, so what are the basics? Yeah? Common factors, basics, things like vulnerabilities, older systems, unpatched systems, weak credentials. Those are all very present in a sector like healthcare. So, again, pointing at my predecessor here, you don't need to care about APTs or very advanced stuff. Let's solve the basics first. Let's address the basics first. Because when we address the basics first, we'll already have gone a long way.
Thank you. I love how the presentations all connect, Joao's and Stefan's and Martin's keynotes. It looks like we have some recurring patterns to learn from and bring back. Any questions from the audience that we can help answer? We have one question here in the middle. In the middle.
Hello, thank you. Thanks for the presentation, very interesting. One question comes to my mind. You often mentioned that during your investigation process, you just need to get your data and do your investigation. But how often before the product is actually installed, do you have any interaction with the security teams of the venues where you install the machines to discuss whether there are some tuning you can do to integrate it with their SIEMs, or there is any kind of security measure they have that could be better integrating with the product you provide, and rather than working on that when the incident already happened?
That's a very good question, and I understand you are looking specifically into are we interacting with our product development teams, correct?
I mean, more like, I guess, Siemens has some products that you help offer incident response when those products are hacked. Before these products are installed in a hospital, for instance, do you have any point of interaction with the hospital security team?
One of with the hospital security teams, that's something that we could improve, to be very honest. Internally we discuss attacks, attack patterns, controls, are those sufficient or not. With hospitals we have exchange over the health ISEC, so there is an ISEC for the healthcare sector. Our company is frequently presenting there and bringing exchange, especially vulnerability management is a very present topic. If you have more interest in this, take a look on the health ISEC, so it's a threat sharing group for the healthcare sector, and you'll find not only us, but some of the other vendors and the key players from the ecosystem coming there, sharing insights and helping improve the situation as a whole.
Thanks.
Thank you.
Last question in the back.
Thank you. Thank you very much for your presentation. I would like to ask something related to what you just asked before. How do you monitor if something anomalous happens in your network at the hospital? Do you have some sensors that detect anomalies?
Let me rephrase that question. Are we, as a vendor, as a medical device vendor, monitoring devices on the field? No, we are not. That's when I mentioned there is a responsibility model on healthcare, and that's these devices, they are owned and operated by the customers. Therefore, we provide guidance. There are even some initiatives towards that, but that's something that's not done by the manufacturer.
Okay, perfect.
Thank you.
Thank you.
Thank you very much. Thank you all for sharing some interesting insights into the specifics of the